When working with the definition of rational exponents, it's helpful to understand how rational exponents relate to radical expressions. For any rational exponent m over n in lowest terms, where m and n are integers and n is greater than 0 because we can't divide by 0, then the nth root of any number a raised to the nth power is equal to a to the m over n power. If n is even, then we know that a must be positive. So let's work through some examples. In number 10, this is 4 to the 1/2 power. Using the definition, this can be rewritten as the square root of 4 to the 1st power. Well, that's the same as the square root of 4, and the square root of 4 is 2. In number 11, 8 to the 2/3 power is the same as the cube root of 8 squared. So this is the cube root of 64 when you square the 8, and the cube root of 64 is 4. In number 12, the negative exponent means it's actually on the bottom of the fraction, and 125 to the 1/3 power means the cube root of 125. 125 is a perfect cube, so this is 1 over the cube root of 125 is 5. And number 13, we have 1 over the cube root of x to the 4th. So this will be 1 over the cube root of x times x cubed. X cubed is a perfect cube, so this is 1 over x times the cube root of x when I take the cube root of x cubed. In the next video, we'll talk about how to deal with what you do when you have a radical expression left in the denominator of a fraction. In number 14, this is the same as the 6th root of 64a to the 12th raised to the 5th power. When you apply the 5th power to everything inside the parentheses, this becomes the 6th root of 64 to the 5th power times a to the 60th power, because we multiply the exponents. 64 to the 5th power is actually a perfect sixth. When you take the 6th root of 64 to the 5th power, it turns out it's 32. A to the 60th power is a perfect sixth because 60 is divisible by 6. So this becomes a to the 10th power. If ever you're unsure about whether or not you can determine the root of a large number, put it into the calculator and see if you get a whole number. And number 15, I'm multiplying. Whenever I multiply, I add my exponents. So this is x to the 2/3 power plus 5/3. Well, this is x to the 7/3 power, which means the cube root of x to the 7th. This means the cube root of x times x to the sixth, where x to the sixth is a perfect cube. So this is x squared times the cube root of x. In number 16, even though your expressions get complicated, you still work with them using the foundational rules for exponents. I'm multiplying two terms together, so that means I will add the exponents together. So this becomes x plus 9 to the 2 plus 1/3 power. In order to add two fractions, you have to have a common denominator. So this is going to become x plus 9 to the 6/3 power plus 1/3 power, where I make the 2 6/3. When I add those two exponents together, this gives me x plus 9 to the 7/3 power. This means the cube root of x plus 9 to the 7th power. This can be factored into the cube root of x plus 9 times x plus 9 to the 6th power. And this is a perfect cube. So the cube root of x plus 9 to the 6th power is x plus 9 squared times the cube root of x plus 9. Remember, the product property allows us to pull a product apart as long as I use the same index on the radical. So this expression is equivalent to the square root of 25 times the square root of x plus 2 squared. I can work with each radical independently, and this is 5 times the square root of x plus 2 squared is just x plus 2. And then I distribute my 5, and this is 5x plus 10. In number 18, we have the root of a root. So, in order to evaluate the root of a root, I need to separate these two apart, or I need to make what's inside underneath a single radical. Okay? You can separate these two apart and say the square root of x times the square root of the square root of x. Instead of doing that, I'm going to force my x on the outside of the interior square root back into it. If I have an x on the outside of a square root, that means when I move it inside the radical, it had to have been x squared. So this is equivalent to saying the square root of the square root of x times x squared. Just to clean this up a little bit, this is the square root of the square root of x cubed. And then my root of a root property says that I multiply the indexes together. So this will be the fourth root, 2 times 2 is 4, of x cubed.